7, 8, and 9. Okay, we have, for this class, we have 4 major types. And I mentioned before, I'm skipping the 5th major type, and we'll take that up in 1412. So these are the sections we want. Notice we're omitting section 5 forever and ever from this chapter. So we had 4 types of reactions. We had combination. Remember, it's also sometimes called composition, means the same thing. What's another one we had? Decomposition. And these two are the reverse of each other. That's why some people prefer to call this one composition. You're composing, or putting something together. And this is decomposition. You're ripping it apart. Okay, then, what's a third one? Single displacement. And our final?
Double
displacement. Now, in your textbook, they just call this one displacement, but I like to make it more descriptive. On the test, I will pencil in the word single. And then double displacement, they refer to it as metaphysis, but again, that's not a popular term at all. And this is much more descriptive, double displacement. And I had up here one day the same stuff, so let me put it again. What you have to be able to do for a combination, all you have to do is recognize it. With a combination, you have 2 or more reactants, and you get 1 type of product. Okay, 2 or more reactants. You have 2, you'd have a half a dozen. And what do you have to do with this type? That if I say, like in your lab 9, you took magnesium. Monatomic or diatomic? Monatomic, and you reacted it with oxygen. Monatomic or diatomic? Diatomic. And when they went together, we should have gotten MgO, 1 to 1. And just as an aside, let's review this. If you had to write the formula, and for combinations, you do not have to predict products for me. I will give you the products. But if you had to predict how these two would go together, what's the charge of a magnesium? Look at its position. What's the charge?
Positive 2.
Plus 2. What's the charge of an oxygen?
Negative.
Minus 2. So if you did the double cross, you get 2 and 2, but you should clean it up. Lowest whole number ratio, and we would predict this is the formula, and then to balance it, we do that. Okay, for this chapter, what do you need to be able to do? Take a look at that and say, what type is it? And you say, it's combination. And you had a quiz on that type of thing already. How do you spot it? 1 type of product. Now, you may have 2 of them, but it's 1 type. They have combined. You can have 2 things here. These can be 2 elements. They could be 2 compounds. 1 compound, 1 element. That's not the point. That is just 2 things over there come together. All right, this one. We have 1 type of reactant, and we get 2 or more products. Decomposition. Now, for decomposition, I would write out the whole thing for you. That I would have something perhaps like this. And sometimes people include the physical states here, and sometimes they leave it out. If we heat this up, this is what happens. solid and gas. And let's see, to balance that, we have to do that. So you would get the whole thing. Just what kind is it? And because you start with one type of reactant, you know it's a decomposition. Now, some decompositions, when you decompose, you usually have to put energy in, heat energy or electrical energy, sometimes even light energy, because things usually don't just spontaneously decompose. You got to give them a little push, like heat or some form of energy. So you may get a simpler compound and an element, or if you take water and you zap it with electricity, you can break it down all the way to the elements. But again, what type is it? Decomposition, because you started with one type of substance. But I want to point out, some people think to be decomposition, you got to decompose it all the way to the elements, and that is not true. You can just decompose it to simpler compounds, or one compound, one element, whatever. So recognition. So for these two, all you got to do is tell me what type it is. You don't have to predict. Will it go? Just assume it's going to go. And you don't have to do anything with it. You don't have to predict products. You don't have to tell me if it's going to go. But once we hit single displacement, now how do we characterize single displacement? This is what your lab 11 is all about. That you take an element, you react it with a compound, and you get another element plus another compound. Now on this type, I'm going to work you a lot harder, because on this type there's going to be a couple of things. One, predict products. 2, will it go? Okay, so I've just upped the difficulty level on a single displacement. In the laboratory, you could tell if it was going because you could watch color changes or formation of gas, or you could see. But if you don't have a laboratory to go test it out, I believe I pointed this out, then what you use is the activity series. And this is found on page 232. So if you were taking a review, practice review, or taking the test, that and the part kind of in the mustard color over there, that's the important part. Do not memorize that. I will make it available to you, because when you start looking, if you can see, unfortunately it's not good contrast here, but if you see the elements here, there's no rhyme or reason. This is just what was found. It's not like it goes through this period or that period or down this family, that family. It looks pretty random. Like here's lithium and potassium, but then suddenly you have calcium and sodium and so forth. Here's how it's used. Your most reactive, and this is under the conditions about room temperature and in aqueous solution, your most active one is up here at the top, lithium. Okay, lithium under these conditions can kick out anybody below it. Okay, so the way it works, lithium could kick out potassium or calcium or any of them. When we get to potassium, potassium can kick out everybody down here, but it can't kick out lithium. Remember the story about the captain of the football team versus the 90-pound weakling at your high school? Okay, that's the idea. The strong always win, or the active always win. Now, all of these happen to be metals, with the exception, right here, Hydrogen, of course, is a non-metal, and then antimony is really a metalloid.